Hello everyone. This video is to show you how to insert the relevant equations and calculations required to write up the results section of your volumetric analysis practical investigation. The very first thing I'm going to do is get rid of the extraneous information in the introduction section, which includes the description of the assessment task and the assessment conditions. We can just delete that one straight away. There is then basically a page of background information as well as the purpose and aim and the relevant equations and an outline of the 5 steps of the investigation. It's up to you how much you edit this section, but it's for you to present the introductory background information and the purpose and the aim. I'm going to focus on how to do the calculations themselves. So for part A, the preparation of a standard solution of approximately 0.05 molar sodium carbonate, the very first calculation that you were required to complete was to calculate the mass of sodium carbonate that's needed to make up the standard solution. So as we always do with our stoichiometric equations, we write down what is known, so our known values. I'm going to start by inserting an equation so that we get the formatting correct. So our very first known value is the molar mass of sodium carbonate. What I'm going to do here is insert a little subscript function, so x with a little subscript a. My x will be the molar mass, and then I'll use the right arrow to drop down into that subscript section, put an open bracket, and then I'm going to insert the Na2CO3 formula. Again, I'm going to insert another subscript. The sodium will be on this level and then dropping down using that right arrow again, the 2. Use the right arrow again to move back up to the same level as the sodium. Insert another subscript, CO, right arrow 3, right arrow again, close the brackets, and right arrow again gets us back up onto the level of the molar mass. And we can simply write 105.99 grams per mole. And again, I'll just need to insert superscript this time, L, use the right arrow key to the -1, and there I have my little equation. The good news is we don't need to go through all of those steps every time. We can actually copy some of this information. So I'm going to copy that whole equation at the moment for the molar mass and paste, because another known value, relating to sodium carbonate is the concentration which is required, which I know to be 0.050 mole, this time per litre. And finally, the third value, which is known about sodium carbonate, is the volume of which we're going to make the solution. So I'll put a capital V for volume and insert that will be 0.2500 litres in the standard measuring units. However, please note here that you may have used a 200 ml volumetric class rather than a 250 ml volumetric class, and your calculations would need to reflect that, obviously. So there are known values. Now we need to make it clear which equation we're using to relate those values in order to calculate first the number of moles and then the mass of sodium carbonate that is required. So again, insert an equation, and this time we're going to acknowledge that N is equal to C. We're not going to use the X button here because it gives a fancy alpha version of the X. We're going to insert the mathematical symbol, multiplication sign, and then capital V for volume. Again, we can copy in from before our little formula, but this time instead of capital M we want number of moles of sodium carbonate, which is this time going to be equal to C times V, so we can just insert those numerical values, 0.50, again multiplied by 0.2500. Okay, I'm just going to copy this section down to the next level, and the answer to that, of course, is 0.125 mole. we now need to insert the equation that links number of moles with the molar mass in order to calculate mass. So again, one more equation. Number of moles equal to, we're going to use the A on B equation editor part here. Number of moles equals small m for mass, right arrow to get down to the next section, over large M for molar mass, and therefore another equation, small m is equal to n multiplied by capital M for molar mass. So again, paste in the value that we're looking for here is the small m for mass for sodium carbonate, which is equal to 0.125 multiplied by molar mass 105.99. And finally, we've got to finally presenting our mass value, which should be 1.3 grams, correct to 2 significant figures. The reason we're limiting that to 2 significant figures at this point in time is that we, in our starting quantities, were limited to 2 significant figures in concentration. We did have 4 in volume and obviously 5 in the molar mass, which is just a known quantity. So we're limited by the fact that concentration was only specified to 2 significant figures at this point in time. However, the next step goes on to say that you needed to weigh out the approximate mass of sodium carbonate needed for the preparation of the standard solution. Accurately weigh out, that is, and record your measurements. So I'm just going to get rid of that instruction. That's not relevant in terms of writing up the report. And I'm simply going to state here actual mass of sodium carbonate used, and I'm just making up a number at this point in time, 1.324 grams. I'll put that in bold. Okay. The next calculation involves calculating the concentration of the standard solution, this time exact to 4 significant figures. So make sure you're mindful of significant figures as you move through here. So at this point in time, I've just copied from above the known values section so that I can use some of the formatting that I've already created without having to go through the process of doing all of the equation writing again. So in order to calculate the concentration of the standard solution, we again need to know the molar mass of sodium carbonate. We need to know this time, not the concentration, it's not known at this point, but the mass itself, and we take that from the actual mass specified above. So I'm going to pop in here 1.324 grams was the mass actually used, and the volume. So seeing as I know accurately the mass of sodium carbonate that I have and the volume, the linking quantity between those two is going to be the number of moles. I'm just going to borrow again from up here. Oops, number of moles of sodium carbonate equal to, pop that in here. This time I'm looking for number of moles is equal to mass over, molar mass. Just want to get back into that equation there. My A on B, small m divided by large M. I'm going to copy that whole equation. Note how we're always putting in, first of all, the symbol equation and then the actual equation that contains the numbers. Oops. So instead of m, I'm now going to replace that with 1.324, which is my number of grams. Get rid of the large m, replace that with 105.99. And then underneath, finally, paste one more time. Whoops, get back into the equation. And that is going to be equal to, I don't know, let's grab up my calculator. 1.324 divided by 105.99 equal to 0.01249, correct to 4 significant figures. I don't need to round that value up as it's followed by a 1 and then a 7. So my number of moles of sodium carbonate, 0.01249. And the unit for that, of course, is mole. Finally, I need to convert from number of moles to concentration of sodium carbonate. So I'm going to copy an equation that I can use, paste that, replace the N with a C. Number of moles is equal to, concentration is equal to rather N over V. Copy and paste that one more time. Replace those letter symbols with their actual values. So in this case, 0.01249 over the volume, that is the volume of your volumetric flask, which was 0.2500. And paste it one final time and put in the value. So again, bring up my calculator, divide that value by 0.25. And I get a concentration of 0.04997. Oops, I'm typing in the wrong spot, aren't I? 0.04997 mole per litre. And I just need to insert X to the B to get a superscript minus 1. And that is the calculations done for part B. Next, you need to put in the steps to prepare the sodium carbonate solution. What's important here is that this should be recorded in the past tense using impersonal language. For example, the very first step would have been to weigh out your sodium carbonate. So you could simply write 1.324 grams of sodium carbonate was weighed on a watch glass. That could be your first sentence right there. So those few examples should give you enough of an idea about how to work with the equation editor and how to go about formatting your equations so that they're using correct chemical conventions. So if we now scroll down to part B, I'll just quickly run you through a couple of things. So again, you need to be referring back to the method all the time to make sure you're computing the correct calculations. And following any instructions such as this, construct a table to record the initial reading and the final readings on your burette. You would obviously insert your titer values, your table, right here. It's important that you remember, for example, include units in the header rows of the table, round all numbers to the correct number of significant figures, if I could spell, and include average titer values in that table. Okay. Then when it comes down to calculating average titers, balanced equations, etc., you can use, again, the equations function to make sure that you're getting all of the superscript and subscript numbers in correctly, as well as the correct mathematical symbols such as plus and the equal sign and arrows, etc. for your equations. So you'll need to go and work those through. Nothing more to say about the calculations in this section. It all follows through. So you'll just need to add in each of the calculations in the appropriate space and make sure you space it out and format things so it's all very easy to read and follow. That will lead you all the way up to your summary of results. What I suggest is that you work also with the spreadsheet available to you via Google Classroom, which is called 3.1 Volumetric Analysis Calculation Check. So I've set this spreadsheet up to enable you to check that the values that you are getting via the calculations that you're doing by hand and putting into your report are actually valid. So if you click on the example cells, you'll be able to see I've just put in an arbitrary value there of what my mass of sodium carbonate would have been had I done the experiment. But then each of the cells following on from there actually have equations entered into them, which then follow down to the cells below. So for example here, I'm taking the mass of sodium carbonate from cell B3, dividing it by the molar mass of sodium carbonate, which is going to give me my number of moles of sodium carbonate, and then dividing by the volume, so number of moles divided by volume is giving me the concentration of sodium carbonate overall. And it'll be the same for you, and you can use this as an opportunity to check that the concentration of sodium carbonate that you got, first of all, was very, very close to 0.05 molar, it should have been, and that also it was correct for the values that you're putting in. Following on from there, the titer value in each spot is blank. That's because that doesn't depend on anything else, but the concentration of dilute hydrochloric acid depends upon the concentration of sodium carbonate calculated, which is then multiplied by the titer value, C times V, and multiplied by 2 because of the mole ratio between hydrochloric acid and sodium carbonate in the balanced equation, which is then divided by this value in D3. So all across you can see that the different cells have formulae that relate to each other, and it works all the way across to the point where we work out how many moles of hydrogen was consumed per tablet. I might just change that right now, that's not very good language there, per tablet, which you can then use when you come back to actually comparing two different types of tablet, the tablet that your group worked with and a tablet that another group worked with. In a subsequent video, I'll talk more about the error analysis and analysis of precision and accuracy, but hopefully this gives you enough information to get all of your calculations done. Thank you.